In this video, we're going to practice augmenting matrices and then row reducing them. So to start off, we can identify our variables in the problem. We have x, y, and w. Those are the only three variables that come up in this problem. So then we can write our columns with all the x values in the first column, all the y values in the second column, and all the w values in the third column. And then we write the value after the equal sign at the very end. And we're just going to do this until we fill in the matrix with the values that were given. So we've now augmented our matrix. So now what we want to do is find a way to make every leading number to equal 1. And so what we can do with that first row is we can multiply it by, and we can also do this for the fourth row. And so we'll get the matrix 1, 7, 3, -4. The middle two rows stay the same. And the last row becomes 0, 0, 1, -1. So now our first column has a leading 1. Our first row has a leading 1. And our second row has a leading 1. And now we want our third row to have a leading 1. But we do not want it to be under the leading 1 in the second row. So we need to find a way to change this leading 1 to a 0 and get a leading 1 either here or here. And so what we're going to do is subtract the second row from the third row. I'm just going to write a -1. So what we're doing is we're multiplying the second row by -1 and then adding those values to the third row. And we'll get the matrix first two rows stay the same, but the third row becomes 0, 0, and we'll get -1 times -1 is +1. Then -1 times 3 is -3 plus 1 is -2, and our fourth row stays the same. But now we can't have these two rows both have a leading 1 in that position. So now what we're going to do is multiply the third row by -1 and add it to the last row. And so this matrix is going to become, in editing this, I realized I put a 4 instead of a -4. The first three rows stay the same. And the last row becomes -1 times 1 is -1 plus 1 is 0. And -1 times -2 is +2 plus -1 is 1. So now this is our matrix in row echelon form. Now we're going to go back to the first example and take what is a matrix in row echelon form and turn it into reduced row echelon form. And since it's already in row echelon form, there are just two more rules we need to apply. So the leading entries in each non-zero row has to be 1, which we have here. We can ignore the column on the right because it's our values after the equal sign. It's our answers, what we're trying to find. So we can ignore that. We don't have to put that column in row echelon form. And then each leading 1 is the only non-zero entry in its column. So we have to turn all of these numbers to 0 somehow. We're going to do that through elementary row operations. So the first thing we can do, we can take this third row and multiply it by 1 and add it to the third row. And so we're going to get we're going to have 1 times 1 plus negative 1 is 0. So we get 0, 1, 0. Negative 2 times 1 plus 3 will be 1. And then we'll have 0, 0, 1, negative 2, 0, 0, 0, 1. Next, we can multiply the third row by negative 3 and add it to the first row. We'll get 1, 7. 1 times negative 3 is negative 3 plus 3 is 0. And then negative 3 times negative 2 is 6 plus 4 is 10. And then the rest stays the same. Next up, we need to get rid of the 7. And so we're going to multiply the second row by negative 7 and add it to the first row. And the resulting matrix will be 1. 1 times negative 7 plus 7 is 0. And then 1 times negative 7 is negative 7 plus 10 is 3. And then everything else remains the same. And so now our matrix is in reduced row echelon form. For our next problem, we've also been given the variables x, y, and w. And so we can write our matrix with the first column as our x values, our second column as the y values, our third column as the w values, and then our last column of the values after the equal sign. And so we want our leading number there to be a 1. So what we're going to do is we're going to swap the first and second row. This is called interchange. And so this is just going to become, our numbers are going to stay the same. However, the location in the matrix is going to change. And now, we don't want this 3 here because we already have a 1 in that first column as the leading entry. We're going to multiply the first row by negative 3 and add it to the last row. And so the first 2 rows stay the same. But our last row becomes 1 times negative 3 is negative 3 plus 3 is 0. Negative 3 times 3 is negative 9 plus 2 is negative 7. Then negative 3 times 5 is negative 15 plus 5 is negative 10. Negative 3 times negative 2 is 6 plus 6 is 12. And we don't want these 2 rows to have the same leading numbers in the same column. So we're going to multiply the second row by 7 and add it to the last row. And so now this matrix becomes, first row stays the same, as is the second one. The last row becomes 0, 0, because 7 times 1 is 7, plus negative 7 is 0. Then 7 times 4 is 28, plus negative 10 is 18. And then 7 times negative 5 is negative 35, plus 12 is negative 23. And then to get a leading 1 in this row, we're going to multiply by the scalar value of 1/18. And so our row reduced matrix will become 1, 3, 5, negative 2 along the first row, 0, 1, 4, negative 5 along the second row, and 0, 0, 1, and then negative 23 divided by 18. And now our matrix is row reduced. I'm going to remove the negative 23 over 18, and I'm going to write b equals negative 23 over 18, and I'm just going to put b in there. And at the end, we can compute what that'll equal. And so what we're going to do to get this matrix into reduced row echelon form is we're going to multiply the third row by negative 4 and add it to the second row. And we're going to multiply the third row by negative 5 and add it to the first row. So now our matrix is going to be 1 times negative 5 plus 5 is going to be 0. So we get 1, 3, 0. And then we have b times negative 5 will be negative 5b plus negative 2. So we'll have negative 5b plus negative 2 is negative 5b minus 2. For the next row, we'll have 0, 1, and then 1 times negative 4 plus 4 is 0. And then b times negative 4 is negative 4b minus 5. It'll be plus negative 5. So we'll have negative 4b minus 5. And then our last row stays the same. And now this is almost in reduced row echelon form. However, we just need to get rid of this 3. So we're going to multiply the second row by negative 3 and add it to the first row. And we are going to get 1, and then 1 times negative 3 is negative 3 plus 3 is 0. And then we're going to multiply this by negative 3. And so that's going to be positive 12b plus 15. And we're going to add that to negative 5b minus 2. So we'll have 12b plus negative 5b is 7b, and then 15 plus negative 2 will be positive 13. And so we'll have 0, 1, 0, negative 4b minus 5, 0, 0, 1b. And so now this matrix is in reduced row echelon form, but I'm going to put the b back, the negative 23 over 18 back in for b. So we will get 7 times negative 23 over 18 plus 13, and then negative 4 times negative 23 over 18 plus 13, 0, 0, 1, negative 23 18ths. And that's how I'm going to leave it. You can simplify it if you want.